Whoopsies. Is that visible? That shouldn't be an issue. Okay. Are we up? Are we up? Sure hope we're up. Oh, you know what I can actually do now? Kind of cool. I have Spotify on here. Because I don't think you guys are able to hear this, which is kind of what I want. I don't want you guys to be able to hear it, so I don't get in trouble. That doesn't feel appropriate. Put this on there. Seems reasonable. Okay. Okay. I'll start the thingy now. Okay. I've never done anything like this before. Do I just go? Do I just start talking and doing what I wanted to do? I don't know how I feel about this. This feels... I don't know how to feel about this. I'll tell some of my buddies to come in and be stupid. I think that would be kind of funny. So just give me 2 seconds to set up here. See, because I have my monitors like all in the way. I'm gonna tell you. I'm gonna tell. Who else would be funny to have in here? You wanted to know when I was streaming. And then you can know. You can know. I think that's everyone. You know what I can do? I can do it. I can put it on Twitter. I can just do it in the replies because you're like not supposed to. What do you call it? You're like not supposed to put links directly in the URL for whatever reason. Or for it, you're not supposed to put links directly in the tweet for whatever reason. And then I'll actually get started. Okay, so the point of this is I wanted to talk about P2996, which is the C++, what would you call it? It's like a request for the standard library. It has a name. I had it open here. It is the proposal P2996, which I can kind of show y'all here. Let me like close out some stuff. Do I need to keep that open? No. Okay. So P2996 has this fun stuff called reflection, and reflection is basically when the compiler, get this, compiles your code, it knows things. I know. But during the lifetime of your program, some of those things that would be really useful to know, you don't have access to as your program because the compiler operates on those things and then gets rid of them. But the proposal in this version of the compiler is that you can choose to store some of that information in your program so that during runtime you can use those things. Now, what does that mean? That sounds kind of abstract and useless. Well, let me show everybody. If I env into reflection.cpp here, which is this thing that I was working on before this is kind of the test, right? One of the biggest things in C++ is like, oh my god, there needs to be an enum toString thing, but there isn't. And what people's old solution used to be was you would have like standard string, like entity kind names, and then like, I don't know, however many names there were, so there's 5 there, and then you would initialize that as a list, and then you'd have like player kind. Now, why did it go ahead and do that? Player kind, zombie kind, skeleton kind, slime kind. Okay, right. So this is what you'd have, and then you'd have like some, you know, get entity kind name, right? This is also going to return a standard string. And this could like really be a string view or something along those lines, and then this would take in an entity. This can take an entity kind, and then you're going to like return entity kind names, cast that to it. There we are. And that's probably how you would do something like this previously, right? The problem is that this sucks, because now every time you want to change this up here, you got to add a new one down here, and you are prone to mistyping things, and if you want to reorder things, you got to remember to reorder them down here, and then this number also needs to change. So you could probably do some macro bullshit. You could definitely do some macro bullshit to make this work. And that's what people were doing for the longest time. There are macro-based reflection libraries. Who is pinging me? Why am I being pinged? There are indeed reflection libraries. I know who's pinging me. I know who's pinging me. What was I saying? Right. But there are these macro-based reflection libraries, but those suck because they suck. Why are we using why are we doing macro things for this? That seems real bad. So what I've got here is a remedy to that. How many lines is this? 16. Like 12. Oh, nailed it. Okay. What this does here, and let me kind of DL this because this was something else I was going to do, but I decided not to. This code here that you're seeing is effectively the same thing as what I just showed, except there's no extra, well, there is extra code for it, but it works significantly cleaner, which I'll kind of go over why and how. So there's kind of 2 things that are important to look at here. We have this get enumerators and we have this get enum names. And this obviously is kind of what we were looking at before, where you can kind of see you have this string view, the string view iterator, and you can kind of iterate over these names. And this, I really hate the auto keyword. And most C people hate the auto keyword, and most C++ people use it all the time. But it's necessary here. I shouldn't say it's necessary, but it's encouraged here because basically we construct this vector of enum of string views, and we don't construct a vector, rather we construct an array of string views, standard array string views. And what's frustrating about this is that we have this num enums, and this needs to be known at const eval time, which is compile time effectively. That's after macros, so it's like macros, and then your like const evals and const expressions, and then your actual compilation process, and then your runtime stuff, right? So this needs to be known before that. Like, this needs to be baked into the program. This can't be generated, which you can get it through some template stuff, which is what I do right here. So you have this constructor int, and then we get the number of enumerators for the type. So it's templated, and it's const eval. So this is not changeable. This is a set in stone number, and it's 5 right now because there are 5 things here. So let me kind of explain how this works, because this is really easy to explain. We have, your template, your type name E, get number of enumerators here, and we have this cat ears operator here, and this is new to P2996. And what this means is we have this meta object, as it's called, and the meta object contains the compiler information that I was talking about earlier. So it contains, for example, the meta object of entity kind actually contains each of these fields, each of these enumerators. Whereas during runtime, this entity kind is just a size. It's literally like an integer. Like, you can cast this cleanly to like U8 or whatever. I guess it would be U32 by default. But like, I think you can change it by like U8. It's something array, whatever color. I might go over here. I'm not particularly sure off the top of my head, but it doesn't make a difference. My point is, if I try to do like entity kind dot like get enumerators, right? Like, I'm just making up some bullshit. Enumerators, like, this doesn't exist. This is not a thing, because, and it really can't be a thing by any sense of the term, because entity kind just compiles down to an integer, and each of these is just like 0, 1, 2, 3, 4, etc. So I guess it kind of makes sense to have like a none kind here. I think that would make more sense for 0 and none kind. That's actually what I do in my engine. So like I said, we have this cat ears operator, which returns the meta object of the type. Now, you can generate a meta object from a type. We're going to do some experimenting, because I don't fully understand all of this. So I'm going to see what runtime effect this has. I think it just yells at you if you try to do this on something that isn't known at compile time. But we will find out. But when you use it at something that's known at compile time, like a template, it returns this meta object, and then we have this standard meta library, which is also new to P2996, and that has a bunch of really, really cool functions. For example, enumerators of, which you pass in this meta object, and then that will give you an array of all of the enumerations. So that gets used kind of down here, and I'll get into that in a second, but it doesn't really matter what type this returns, because we know it's some array, and we could just get its size just like that. And because this is an array, and this is known at compile time, and this is known at compile time, we can do this on const eval time, and it's really, really, really quite simple to do. So with that in mind, this will give us, which is still even useful, the number of elements in this enumerator, which again you can't easily do in just regular C++. Like, is it 20? Are we up to 25 now? Oh, because this is 26. We must be up to 25, but I don't know if that's true. I use 26 on the daily anyway, because I like the pound embed. I need this for my engine. And that is also introduced in 26, but like not P2996, a different. Actually, like GCC has it implemented already, despite being experimental. So I've been using GCC, and it's really, really nice. But this is Clang. I'm pretty sure Clang is the only compiler that actually has this implemented so far, as according to the standard. Anyway, as I was saying, we're gonna have this get enum names thingy here. I shouldn't call it thingy. It's gonna, like I said, it's gonna return auto, and it's going to return a standard array of string views, and its size is going to be the num enums here. And like I said, if this is known at compile time, you can't do this at runtime, which is a little frustrating, because we use this enumerators twice, which is kind of annoying effectively, because we do it down here as well. I'm not a fan of that. Maybe there's a way to not have to do it like that. I don't know. Well, it is admittedly a little frustrating to have to do this twice. So like I said, let's think about this. So we have this size, we have this array of names, and it goes string view to names, and we don't initialize this yet. Now we have the standard vector of meta info, and meta info it's kind of like a generic container of information. Again, I don't fully know everything about it, but we have this array of them, or we have this vector rather of them, and we're able to get that by doing standard meta enumerators of, and then the meta object again. So the same situation do up here with the cat ears operator. We do down here, and this enumerators of gives us a vector of meta info. And then to populate this names up here, we iterate over that. And I guess this really could be a... Why do I do it like that? Am I stupid? Let's try something. So let me quickly go ahead and... What does it be? Yeah. So we're going to do... do I need to source bash RC? I'll do it. I do it wrong. Is it this one? Oh, boy. Oh my god. Jesus. Right, so we're gonna do and I should be in, so I can go to C, home, and then reflection adventure. And I just want to be there, but I'm assuming I already am. Right. And we're gonna do P2996. We're gonna pass in parser. No, we want to pass in reflection. Reflection.cpp-o main, and then we need to do /f reflection to tell the compiler that we want to enable those features. Okay, we're gonna comment this out. Okay. Awesome. So that worked. So now if we run main, beautiful, look at this. As you can see, it takes our names that we get from here. It's const. And again, this expands to something like, I'm pretty sure I could just type it. Like this auto will expand into standard. I had it. Right, standard array. Oopsies. Of standard string u, and then, so in this case it would be 6. That should effectively be the same thing. Right. And again, that's frustrating because let's say I add in like, I got slime kind, that was gonna be my example. We could do like, it doesn't really matter. What have I been playing? Like creeper kind, I don't know. Now it's going to yell at me because, right, this doesn't expand to the same type. But if we do, 7, obviously, now it's going to work. And we've got our creeper kind down here, right? So that's really, really awesome, except having to change this kind of sucks. And, you could do, to that point, get, oopsies. You could just as easily do get num enumerators with a... Dude, why do I suck at typing? This is embarrassing. Get number enumerators, any kind. Like so. And that should also work. Oh. Whoopsies. Dude, I actually can't type. This is embarrassing. There we go. Same situation. So exact situation. So, I mean, obviously that's a bit obnoxious. So, like, you could save it to a variable or something. I think it would still have to be constant. You have to constant num equals get num also should work. Right. Again, all of these are equivalent. I'm kind of being a little pedantic and redundant here, especially because what I wanted to do was change this into something else. So we have this enumerators here. So what I'd like to do is for standard meta info, and we want to get a reference, and this can be a constant because we're not going to be changing anything here. For every, we'll call this like meta. We'll call this like minfo for meta info of the enumerators. Right. Oh, that's why. That's why. Because we're populating. I see why. I see exactly why. Okay, so that makes sense. Because we need to populate this array. Because it is an array and not a vector. So like we could do this if we were able to push back. But standard vector is not compile time compatible, I guess, for the lack of a better term. But I think it is going to be, like, at some point. I remember hearing that was going to be a thing that was happening. But it isn't currently. So with that in mind, what I wanted to do is mess around with this a little more with a structure, because an enum is simple, but I wanted to try to make something that I thought was cooler. So instead, I'm going to try and implement something that I had an idea for my game engine, but I mean, I'm not using an experimental compiler version for my game engine. I'm not using Clang for my game engine. I'm using GCC. But we're going to try it anyway. So the first thing I want to do is I want to define a generic game item, and we're going to just call it item. But think of this like a game item like Minecraft. So we'll call this like a game item. And this is going to have an item type, enum, item kind. And we're going to do this the kind of naive way, item none kind. And this really should be entity none kind. Item none kind, and then, I don't know, we'll have like a sword kind, bow kind, shield kind, and then like chest piece. Chest plate kind, right? That seems reasonable enough. And then this is going to need an item kind. Cool. And then I need the thingies. Whoopsies. Then, just as much, for the system I wanted to try doing this with, I wanted to do an enchantment system. And I, for this experiment, want to try listing every enchantment and its value at runtime. You'll kind of see what I mean here. So we're going to do type def struct. We're going to do this, and then we're going to do, we'll call this enchantments. And I've never worked with like a struct and a struct here, so I have no idea how this is going to go. We're going to try it. And we're going to do like int sharp. Or we can do like a, hold on, gotta do the thing. Is it typed up? Am I being stupid? Hold on, I'm being real dumb right now. Excuse me. What is it for? Is it? Dude, I feel stupid right now. Type def. Oh my god, what is the type def macro? I've done this a million times. Define, Jesus Christ. Define, and then is it Q8 is unsigned car? Oh my god, I'm gonna lose my mind. Yes, okay, that is it. I'm so sorry that you just had to watch me do that. That was kind of pathetic. But I'm kind of losing my mind. So we can do like U8 sharpness equals 0. And then we can do like U8 why am I being stupid? What a power equals 0, and then we can do like protection. Now, really, these equals zeros are going to be redundant, I believe, but just for the sake of it. Now, again, I've never really worked with structs inside structs, so we're going to see if that worked. No, it didn't like that. U8. Type is not C compatible due to this default member initializer. Oh, okay. Well, there goes those, I guess. Whoopsies. Whoopsies. I'm using this while SSH'd into a server that is like in my house, but it's not wired into my computer. So it's going to be a bit chapped and a bit laggy. Okay, so it liked that. That's fine, I guess. So what that means is I should, down here, if I was to, and I guess I can kind of, I want to delete this stuff. I'll keep it. It shouldn't be there. So. And then we're going to do like, call this like item stuff. And then we need like we need a new instance of this item, and we'll call this like test item. Should zero out the memory, and then we want to do %d, and then, or no, it's a %d. That's fine. Test item dot. Is it now? Is it dot? It should just be dot sharpness. That's gonna kill me. I don't know why I keep forgetting that's happening. That should just work. I really feel like I'm being stupid. Because I guess you can't zero an array like that. Like I thought you could. That's fine though. Now, how do I give this that? Are you dumb? Do I have to like... I guess that would make no sense, wouldn't it? Okay. Beautiful. Okay, that makes sense. And then I'm gonna kind of oh my goodness. Okay, that works. And I'm gonna remove that last section. It's kind of funny. Okay. With that in mind, let's get experimental. So the goal is I would like to be able to modify these and be able to print them out during runtime without getting some sort of like other array of these names is kind of the goal here. Now, let's think about how we might do that. So how did we do this here? So we have this typedef get number of numerators, and this code is loosely adapted from some like blog post that talked about P2996 because it's been around for a minute, like at least a year or two from what I can tell. And this was kind of the test of like, you know, what can reflection really do? So with that in mind, let's kind of think about this. So we definitely are going to end up needing this identifier of. And what we're not going to need is this enumerators of. There should be a non-static members of. I believe is the thing. And then we're going to need to do this all in like some templated const eval stuff as well. So let's just start writing some stuff, because I think that that's usually the best place to start. Let's just put some shit down. So we don't necessarily need this to be templated, because it's only going to work. It's only going to work for this enchantment stuff anyway. So what is the first thing that we need here? I guess the first thing that we get, let's start easy and just print the names of all of the enchantments. Let's just do that. So we'll do our const eval auto get all item enchantments. Oh, but that's not going to work, because my goal was to pass an item in here. But that's not going to work, because this is a runtime object. It's going to pass a what do you call it? A reference. But you can't do that, because this is going to exist at compile time. So you can't necessarily do that. I think for now, let's just make this void. And to work on something a bit more generic, we can do like item, like const item and item. Okay. So the goal here for this item specifically is going to be to get all items. If it yells at me, then I'm the worst programmer on the planet. Yeah, see, that's to be expected, isn't it? Like, what are you talking about? Oh. Yo, what are you talking about? Oh, because I'm being stupid. Because I'm being really stupid. Like, someone needs to take the keyboard away from me, man. I just cannot be trusted. It's kind of embarrassing, I'm gonna be honest. There we go. Jesus Christ. Like, sometimes I just really need the keyboard taken away from me. Okay. So with that in mind, we want this runtime method to get all of the information needed from this compile time stuff. So what I'm kind of thinking might be possible is to save this as like a... No, it wouldn't be static. It should be const. So we're going to do... First thing I want to try is const int num enchants. Right. And what that's going to do is we're going to do standard meta... Oh, an equal sign. Constant number of enchants equals standard, holy cow, standard meta, and then non-static members of the meta object of our item. And because this is passed in as typed, we don't necessarily have to take the type of item. It's always going to be a type, and dot size, because it doesn't necessarily matter what we're operating on at the moment. I just want to get the sword. It did not like that. Expressions of const eval only type are only allowed in const evaluated contexts. Right. Okay, so this was something... oh, this is kind of obnoxious, isn't it? Did you mean... to free non-static data members of? That is what I meant. Wow, it like knows. It's non-static data members of. Now let's see if that changed anything. I don't think it will. I'm curious what that changed, if anything. P2996 revision 10 requires an access context argument. What the hell are you talking about? Why? So let's kind of take this from the top. Okay, right. Okay, so that's it. Non-static data members of is deprecated. P296 requires context argument. That's it. So it still liked it. So I'm curious. Okay. So that's const, and then we can printf. Like, I really just deserve to have the keyboard taken from me. /n numchance. And the goal is to do this without any compiler warning, so I'll deal with that in a second. Oh, that actually makes sense, right? Because we have this kind and we have this enchantment. So it's actually getting the wrong thing here. So how do I access enchantments from within that? Is it as simple as item.enchants? Cannot reflect the provided operand. Why? Why can you not reflect the operand? Is it because of the parentheses? Interesting. So let's try this. But I don't think that's going to work. Right. Access typedef struct within struct. Access typedef struct within struct. C++. Oh, I see. It needs to be, aha, I believe. Aha! Had you there. So now it should be 3. Sharpness, power, protection. Beautiful. Now that makes me very, very happy. Okay. Cool. Now what? That's really useful. That's really, 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 truly useful. But why is it? Let me go ahead and read that warning again. P2996R10. P2996R10. What is P2996? You know what I should be doing? I should be doing this so that you guys can all see it too. Wouldn't that make a whole lot of sense? So P2996 P2996R10. That doesn't really help. P296 R10. No, I want to see what changed in R10. Integer sequence. Enum to string. So okay, so this is the example that I stole. And I think the way to alleviate using this twice is to use a template for, which I have not a clue how to do. Standard is enum v? What does that mean? Okay, sure, like whatever. Let's do with that a minute. Okay, so let's look for what it wanted, an access context. The access context class is a structural type that represents a namespace, class, or function from which queries pertaining to access rules may be performed, as well as the naming class. Class.access.base, if any. So what does that mean? What? Ooh, did someone join chat? What in the world is this? Oh, buddy. Okay, so you know how Jai has super splendid compile time stuff? I'm trying to do that with C++, is basically what I'm trying to do. P2996 is a compiler. Damn it, I had the word for it. Proposal? Proposal. I always be forgetting that word. It's a proposal for the compiler to basically add reflection, which is what Jai's like cool compile time stuff does. So the example I was doing earlier was enum to string, right? Take this enum, take all of these, you're able to print them out. The example is right here, right? No second array, no slop, just raw compile time stuff. So what I'm trying to do now is something similar, except with instead of an enumerator, I want to have a bunch of enchantments on an item. And I want to be able to, at compile time, get the list of all of these, and then at runtime, list all the values without having to manually do all of these. Is there a million better ways to do this? Yes, but this is purely for the sake of talking about how to get compiled time stuff to work. So what we're looking at is I'm getting this warning, like it's working fine, but P2996R10 requires an access context argument. Warning, non-static data members of is deprecated. So it's telling me access context current. What if we just do that? What if we just put that in there? What if we just tried that? Requires access context current. Oh, I did mean standard meta access context. Oh. 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 That's how we do things. Okay, what did I just do though? Why did that do anything? The access context class is a structural type that represents a namespace, class, or function from which requires pertaining to access rules. The access context class is a structural type that represents a namespace, class, or function from which queries pertaining to access rules may be performed, as well as the naming class, if any. Let P be the program point at which access context returns. An access context naming class is the null reflection and whose scope is the unique namespace, class, or function as associated with the innermost namespace, class, or block encapsulating P. Okay, so this is kind of like, I'm not messing with the compiler. I'm messing with a compiler proposal. It's this implementation specifically of Clang. But I'm messing with compile time stuff. So This is like a fork of Clang where somebody, whoever Bloomberg is, maybe this is something I should know more about, implemented this proposal for the C compiler, or the C++ compiler rather, implemented it in Clang, and it's experimental, right? So you have to clone the source and build the compiler from source. You have to build Clang using Clang. It's kind of funny. And then you have to do other stuff. Go back, please. I didn't want you. So does P2996 prefer to related proposals also implemented? So expansion statements, function parameter reflection in reflection, annotations for reflection, define static string array object, which can be enabled with the F reflection latest. Think place P2996. Okay. So what is this? Annotations. Since we're removing the ability to put attributes on, okay, this is gonna ever since this, but more since we have been requested to add a capability to annotate declarations in a way that reflection can observe. For example, Jeremy Ong presented a compelling argument in a post to the SG7 reflector. I also noted that need while it was evolving, but at the compiler level, also assuming it's Clang, it's all ULVM. I mean. It's compile time stuff, so it is at the compiler level, but I'm not touching the compiler code. Like, I'm just using what they've given me, and by me, I mean what I'm able to find online. We're going to encode properties. Okay, right, but I don't want that. Rust clap library provides a, okay. Add annotations to declarations to help drive how the parser is declared. We can now do the same. So this is their annotation syntax? That's real ugly. I like Jazz better. Wow, that's cheeks. I don't like that syntax at all. I don't particularly get it, but it's annotations. It's annotations just like it is in Jai, and I'm kind of getting sidetracked here, so I apologize. Yes, it is metaprogramming, exactly like metaprogramming. Right. Okay. Right. So back to what we were doing. Want to. Oh my god, I've already been streaming for an hour. What have I done? I've done nothing. I've done nothing for an hour. Right. So, we've got the number of enchantments. And we can actually get the non-static data members of. So let's be silly. Let's be silly. And let's say const standard array of standard, we want standard meta info, and this is going to be the num enchants. And we're going to call this the meta equals the standard Is this completely redundant? Yes. Doing it anyway, because I think it reads a little easier. Oh, what did I do wrong? Right, well, first of all, I forgot to give it the access context, which I probably only get once, now that I think about it. Oh, it's a vector? Okay, I take it back. Okay, so this can only be ran in const eval. Have you read the No Graphics API blog post from who? From JBlow? You don't read his blog posts. Am I fake? Am I fake Jonathan Blower? I don't read his blog posts. I never have. I'm just a Jai compiler guy. I don't actually care about anything that he's ever done. So this needs to be done. Can I just like mark this as const expression and call it return? No, but so this is what I don't understand. It returns a standard vector. But it returns a standard vector, but you can't return standard vector in a const eval block. So let's like try that. What happens then? Am I being silly for trying to save this? And someone's asking me which API I learned. I think that's a bit too far. I think you should use a graphics API. I think the idea that we should tell people to stop using graphics APIs is kind of absurd. Which one, I think, is very particular and definitely discussion worth having. Yes, I did mean double. Of course, he was shitting on OpenGL before finally showing that post. Which, isn't that funny? Because doesn't his fucking engine use OpenGL? Am I being stupid? Okay. Why did it not like that? Must be initialized by constant expression. It is constant expression. I have it right there. Now, there was something about a const eval or a const eval block. This is a proposal, absolutely. Oh, look, P2996, there we are. So propose it. Now, okay, so let's try this. So static assert some bullshit. What if we did that? No, okay, I think I have the wrong approach to this. So we have this, right? And we shouldn't necessarily be trying to save it because this exists, you know, at the compiler level. No opinion on that. Blog talks about why people, why APIs over there. I should be reading more Jonathan Blow's blogs. I'm sure they're actually pretty useful. Okay, so we have this, and the goal. I mean, the goal really should be, because you can't access this during runtime is kind of the problem. So we need to get out of the way all of the things that we need at compile time, like in kind of our own compile time block. So I think what would be more wise here's what we're going to do instead. That is the world's biggest mouthful. So we have this const int, and then, so within this const eval, now we can do standard vector of meta objects. We're going to do this kind of the same way that we did this a second ago. So standard vector, standard. So I guess this can be constant expression. Right, we're going to do this kind of similar to the way that we do things up here, right? Standard meta info. This is not enumerators. This is going to be the meta chance. And you know what? Actually, this whole line can be deleted. We don't need that. Non-static data members of right. Okay. So we have that. And now what we can do is we can do a standard array of standard string view, and then we can do the meta chance. That should compile. Why didn't I like that? Oh my goodness. Oh my gosh, I really didn't like any of that. Whoa. I guess it didn't really clear. Yeah, you could just do. Okay. Like, that's not obnoxious at all. Okay, so non-static... Oh, I didn't do that. Okay. Non-type template argument is not a constant expression. Right. Because this needs to be known. I'm not particularly sure what to do here, other than just go and to be redundant about it. So for the sake of getting it done, I'm happy to be a bit redundant about it. Equals, oh, and then this thing needs the, it's like the biggest fucking mouthful ever. See, my issue is that I'm kind of tempted to not save these to a variable, because there's no need to, because it's all compile time anyway. It doesn't necessarily hurt. So this, what the hell did I just do? Oh my goodness. Yeah, I actually might be like kind of brain dead. Like, I can't lie to everybody here. Like, I might be a little stupid. Right, like... Again, like I was saying, I really strongly feel like sometimes I just deserve to have the keyboard taken away from me. So that should be fine. I think I clutched that. And then this should be... And then I didn't even give this a name. That's also probably why it didn't work. Call this like chance. Oops. Cool. That worked. Now, what is enchant names? Well, first of all, this is gonna be what we return. So it shouldn't have a problem with that. Cool. It did not. So what do we just do? Basically, we got the number of non-static data members in this struct. Then we got all of its non-static data members, which is going to be these three. And we now have this vector of meta objects that we can only mess with within this const develop block. So we can't return this. This cannot be returned because this causes a heap. I'm not even. Am I even doing the camera? This causes a heap allocation in the compiler. So the compiler program is running and making a heap allocation. So think about what that means to return a pointer to this to the program. The compiler is going to close on my computer. That memory is going to go away. And then what? So that doesn't necessarily work, which means we need to have this array with all of the things. And you also can't really access the standard meta info outside of that either. So we need to get all of the information that we need about this structure before we return out of this function. What that is going to entail, I truly don't know. Let's find out. Let me reply to some people here and then. Okay. So how do we? So I think what's easy here is to populate this array. Like we can very easily copy what I did up there. So for int I equals 0, I plus then chance plus. Okay, now that really should just work. So we should be able to do. Oh, whoopsie. Should be enchant names, right? Yeah. Oh my goodness. Is that not splendid? Is that not splendid? Now, is that exactly what I had above with the enum stuff effectively? Whew. So now what we need to be able to do is turn that back into the actual excuse me, the actual thing. Now there's some real scuffed that I've thought we could do, and for the sake of getting it working, I'm gonna do it, but this is, I have to admit, this is quite devious. I have to admit that what I'm about to try to do is quite devious. Let's do it. Let's just try it. So what we're gonna do, and I almost don't even want to try this because it's so bad. We are going to get and I defined U8 above. So we're gonna take a U8. We're gonna take a U8 pointer called item in the world. So there's this thing called reflection in programming when you're dealing with compiled languages. And what reflection is when your compiler is compiling your program, it is going through and is gathering a bunch of information about the types that you as the user have defined. So if I go up here, you can give an example of a type. This is these are enums, this is a struct, and you have your classes and stuff like that. And your compiler has a bunch of information about this that isn't exposed to you as the programmer, but it would be really nice if some of those things were exposed to us as the programmer, such as how many items are in this enumerator, what are the names of all of the members of the structure and stuff like that. So there is the C standard, and that's basically a group of old people who decide what should be implemented next into the C and C++ compiler, and they have made a experimental version of the compiler that has these features called reflection that let you get some of that information as the programmer. So I'm just experimenting with it, trying to learn about it, and compare it to other programming languages because, as Og knows, There's a programming language called Jai, which has all this stuff in mind, and it's really, 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 really cool stuff you can do in that programming language. So if C++ is going to catch up to more modern programming languages like your Rusts, your Jais, your Zigs, your Odins, this kind of stuff is going to have to work, and it's going to have to work well. But like I said, to start, we're going to do something quite silly. So we're going to call this item pointer. And this is going to be the memory address of the item casted to a UA pointer. And let's see if that works. Okay, it did. Now, it has the item kind, right? So what we're going to do is we're going to say it's that, and then we're going to move that pointer to after the identifier. Is it size up? No, it's definitely size up. Okay. So what we just did is we took a pointer and we moved it to after this, which means the enchantments are next, which are going to go in this order. So we have this UA pointer, which should now be pointing at the value at that location, because it's all contiguous, right? And then we're going to do %d. And this is going to be real bad. We're going to dereference the pointer at item pointer, and we're going to increment. So no matter what happens, the order of operations here should still work, and this needs to be cast. No, it doesn't. Okay, that's so ass that works. So if, for example, before we do the test item, we do test item dot enchantments dot what is it, power equals like power 5. That's so ass that works. That's terrible. That's terrible. This is quite possibly the worst thing I've ever written that actually works. So, like I said, so the memory, here's how the memory layout of this works. So we have our struct up here, and it has 4 things in it, effectively. It has, so we'll call this is our item. It has 4 things in it. It has an item kind, a sharpness, a power, and protection. In this order, because these guys are kind of nested. Whoa. Dude, sometimes I don't like any of them. Sometimes I don't like any of them. And if I was going to do a programming stream, I would have done it in Focus, like I usually do my programming stuff. But I didn't feel like setting up the power on Windows because it was real bad. Anyway, so the layout is kind of like this, but this gets flattened due to the way that the memory layout works. So this is effectively what we're dealing with. So we have this. Are these even tabbed properly? Okay, whatever. So what we do is we take the pointer to the beginning of this, and then we move it over and pretend my cursor is the pointer. So it's going to start here, and we're going to take the size of this item, and we're going to move the cursor over by that amount, which is going to put us here, which is effectively here. It's the same, right? And now we have this list of all of the non-static data members, so we could just start here and increment at each one and get its value. That's real bad that works. Because the second one of these is no longer the right size, you just die. You die big time. You die big time. And that's bad. So what is there for us in order to prevent this from sucking so bad. Because it works. Don't ever ship that. Don't. Just don't. Just truly just don't. So let's get experimental. Let's see here. So there was this. And this had some examples. So let's go ahead and read the examples. Holy Christ. This is real far down. The reflection operator. Splicers. A reflection can be spliced into source code using one of several splicer forms. Produce an expression evaluating the entity represented by R in grammatical context permanent expressions. In type-only contexts, it produces a type. R must be the reflection of a type. In contexts, oh my Christ, no thank you. I don't think that's at all what we want. I'm just going to stop reading that because it looked scary. So these are what we want. Back and forth. Okay. Okay. Oh, this is exactly what I want. Oh, this is exactly what I want. Okay, this is exactly what I want. Okay. Selecting a member bind number for a specific type. This example also illustrates that bit fields are not beyond the reach of this proposal. Okay, so you can return the non-static data members of. Okay. Okay, I think I see how to do this. Okay. Okay, I think I see how to do this. Okay, I think I understand it. So I'm going to kind of take this with me over here. I think I see how this could be done. So you actually can return the meta objects. It's just what you can do with them kind of changes. So I think instead what we ought to do is let me see what he does here. So what we can kind of do here, oh, this will be real cool if this works. We're going to do const eval auto get enchantment from like index, get enchantment from index. And then we can return standard meta non-static data members of. And then we need the elements. And then we can kind of, oh, and we need the meta, this thing. Right, and then we can take the index of this. Right, and that's quite simple. Take the non-static data members, and this returns the meta object. Now with this awkward, really, really terrible trash garbage splicer syntax, what we could do is, so now we don't even necessarily need this. This should be how you would do this. Okay, so we're going to take the item dot enchantments dot, and then the splice operator double colon. Oh, and we also need a yes, yes. And then we're going to do get enchantment from index plus. What are the odds that that works? Probably 0, right? Yeah. Splice operand must be a constant expression. Is that true? Oh, did I do the single thing again somewhere? I did. Dude, I did it a million times. Where was this one? Here as well. A constant expression cannot modify an object that is visible from outside. Okay. Okay. Fine. Should leave us with one error. Read of non-const variable I is not, okay, so that needs to be const. Splice operand must be a constant expression. So that's not quite how I thought that was going to work. Trying to look here for anything else that might be particularly useful. I think this is kind of the one that we really want. Now, what's wrong with or I have it. Let's try this. Which means that this should print all 5s. Okay, so literally the only problem with this is that this number needs to be known ahead of time. So how do you solve that problem? Because like this is the cleanest solution. It's just why am I being called? Who's like no. I don't understand how sometimes I just get called at like specifically the worst times. I have to mod the program so I know, so that it knows who's boss. I'm mogging the program. The program's not mogging me. Is this what the exact fucking use of a template for is? Let's... I don't know why I'm doing it on my phone. Oh, that's exactly what I want. That's like exactly what I want. Okay, so we're gonna change this up a little bit. We're gonna do something a bit different. Actually, let's try this first. So we're gonna do template for right. Okay, so then now how do I get like the index within that? I kind of stopped reading quickly. Okay. A lot of reflection functions return that you need to iterate over, but you need each vector of meta infos that you need to iterate, but you need each meta info in that container to be usable as a constant expression for splicing purposes. The usual enum to string example looks like this. We need e to be a constant expression variable in order for e to be a valid expression. The rules here match the rules for a regular range-based for statement. The internal range variable to loop is declared a static constant expression. The range has to be random access. We see it +1. Where's it? It. see an iterator in here. Like, this is what I want. I just need a version of this that doesn't suck. I guess there's a bit of a different way to do this. Oh, okay. Hold on. Holding. Hold on. We're going to do... Let's change some stuff here. Let's get silly. Here's what we're gonna do. We're gonna make this get all enchantment info, and you're gonna return an array of you're gonna return an array of standard meta info. And instead of doing the identifier of, we're just gonna copy everything over to a statically sized array. Then we can do standard meta, and then what was it? It was shitbags. Identifier of. Thought it was identifier, but I wanted to check. Standard meta of, and we're gonna call this is gonna end up being something different. We're going to call this meta. And then this is going to be get all enchantment info now. Info for const standard meta info and info from the enchant info. We do that, and then we're gonna do, well, let's just try this actually for now. Zero. This should still work. Oh, it did not. Okay, so we're still gonna need, oh, and this needs to be called meta. So it should only have one error. Oh, why did I do that? Where did I do that? Shaman info? Oh, standard. It should only have one error. Oh! Never mind. Why did it do all that? Right. So it kind of makes sense why it did that, I suppose. So this is where the template for is going to come in. Oh, okay, that was much closer. Oh, this needs to be const expression. Oh, you gotta be trolling. Alright. Meta. Const eval only type must either be... Oh, so do you need to be a const expression? Oh. Binding reference of type standard meta info, aka meta info, to value of type const value type, aka const meta info, drops the const qualifier in instantiation of expansion statement requested here. Okay, so what about that did it not like? And why is that different from what he wrote? Const expression auto. Okay, so you know what I'm starting to think? Maybe it shouldn't be this. Hey! Hey! Okay, that's huge. That's actually huge. It's actually huge. Now, how to get the iterator in a how to get iteration number in for each loop. Does not provide a built-in way. Okay, so you have to. That's chopped shit. I think there's still a way to do it though. We can do like. Can we just still like int I equals 0? Like, will this work? It might not. This is like not gonna do what it should do. It should just print 0, 1, 2. Okay. I'm found media. Okay. This is actually huge. You actually caught this at a splendid time. So we need to do item dot chance dot and then the splice operator, and then what would it even be? Is it get enchantment from index still? Get enchantment from index I? This is still not gonna work, I don't think. No. But this will still work. We'll just print 0 for everything. No? Oh, because enchant doesn't exist. Enchant. Minutes. I am doing a cool enchantment system. Okay, so that should print all 0s, and then if I do this, it should print all 5s. Jesus Christ. Oh my god. This should print... all 5s? Okay. So this is actually huge. So what is happening is this is being expanded. Kind of like how the compiler expands a for loop for you if it notices that it can be. Unless it's like marked as volatile or whatever. So what that means is the last step is I need to be able to make this run, like be expanded properly with this. How do I do that? Surely in the Stack Overflow there was a hint on how to do that. Template for auto. Okay, so how can we get index during template for C++? No, this is not what I want. C++ P2. Let's do something else instead. Whew. Okay, let's try. Int I equals 0 is less than, how much even should this be? Enchant info.size, probably. Is that gonna work? So we do enchant info I, and then this now exists within the for loop. Especially with const eval only type. Anything about, does this need to be? That? Oh, that's real close. Does it need to be const eval? I called this enchant info, enchant info. Const eval can only be used in function declarations. Nope. So const expression might be more way to go. I declared const here. Right, okay, so cannot assign variable I, or, right, okay, that makes sense. Expression of const eval only types are only allowed in const eval. But is this not that exact thing? Holy LARP. It is LARP. All I do is LARP. The range of spirit is specifically A+1 is to be valid. Maybe I'm being stupid here, right? Because maybe I don't necessarily need to pass the index. I can just... And this is... Okay, this doesn't even give me anything useful. I'm kind of looking at this incorrectly. This can be... Oh my goodness. Am I silly? Am I actually quite silly? So what did I even have earlier? Let me like you... Oh my goodness. Oh my goodness. I just undid. So redo nvim. That's super embarrassing. Okay. Okay, how do I force? Oh my goodness, I have... Oh my god, that would have been super embarrassing. You didn't try doing it with correct spelling and no comma. No, it's... Okay, so I think I figured out what I need to do. It was here, right? So the issue is that you can't declare it like that. So we need to do auto meta is, and then this is going to be of the enchant. So this is going to be for every meta object in the enchantment info. Get the meta object, get the identifier of it, and get the data of that, and then we should just be able to pass the meta object like this, right? Oh, no, I didn't. Let's save. Whoopsie. All right. I really thought that was going to work. Does this need to be marked as const eval? There's no way. Call to immediate function standard array meta info 3 is not a constant expression, but it is. I have it marked as constant expression, and plus it can get the type. So why is it yelling? Over to the Pokemon game. I'm actually high-key still making it. This is kind of the funny part. Oh, because I didn't mark it as constant expression. Oh my god. Bang! Holy shit. Holy shit. That's so cool. That's really cool. That's really, really cool. So this is really powerful. That's awesome. I'm kind of ashamed it took me that long to figure it out. And -1 Vim mishap later, that would have been super embarrassing. That's super cool. Okay, so like I said, right? If you wanted to have like a UI object that prints all of the items, you know how bullshit that would be if you had a setup like this? Like, look at how simple this is. I can just add another enchantment, like efficiency. Right? Now, it has to stay defaulted to that. But if I do test item dot enchantments dot efficiency equals 5, build it, run it, efficiency 5 right there. Look at how easy that is. That is so powerful. No code changes for that. No bullshit macro stuff. Oh my god. That's super cool. That's super, super cool. And that explains what template 4 does. So I didn't know what template 4 did before this. That's really cool. That's really, really cool. If this gets accepted, I will be using it happily because that's awesome. Oh, this is going to be a fun one to edit down as well, methinks. But that's metaprogramming. I mean, that's... No, I'm not. This is just an example, like, of the feature of metaprogramming and what it could be useful for, or reflection, rather. I guess it is metaprogramming. You have meta objects, right? It's right there. It's just an example because I've been thinking about an enchantment system a lot recently. Because I am making an enchantment system for a game, but that's not this specifically. This is just given the feature of the compiler, what can you do with it? So that's really cool. I knew I was missing something over here, so that makes sense. Okay, so I think that's kind of all I really wanted, and just for the sake of like changing the numbers around, like this can technically be like, you know, efficiency 214 and like fucking 2. It's pretty cool. That's really, really cool. Which also means, actually, I don't even have to do all of this, right? I could do something like Oh my god. So like I could do, so like our item kind here is gonna be, this is gonna be a sword kind. Sword kind. This is a dot, what do I call it? Dot item kind? Or just kind? And dot. And we can have like dot 5. Is that gonna work? I don't remember how to do the initializers like that. That key might not be how it works. Oops. Yeah. Look at that. Look at how cool that is. Like, where's I'm already on break. I'm home. This is home. I'm on break. I do start a full-time job on the 18th. Maybe. They sent me an offer and I sent them a counter offer. So we'll see if they respond. And that'll be really, really cool because it's programming. It's programming video games, actually. Indie game company. Okay, so let's get silly. Ready? So let's add breaking. Oh, oopsies. Huh? Remember reference base type int? Oh, I didn't save. Look at that. Now, so is Metacompiler a piece of code that can translate its own code into other languages? No. You can think about it like that in terms of its, you know what? So my plan was to turn this into a YouTube video. So let me like explain this now, and then I can like shoehorn it into the beginning of the video. So for those that don't know how a compiler works or kind of what we're doing here, so we have our source code, and this is going to be our int. Let me kind of color these differently. So we're going to have our like return types, which I don't know, that feels green to me, except it can be like a darker green, like an int. And then we have our expressions, which are kind of more generic. So they can be main. These are kind of user defined, except it specifically looks for main. We have our arguments, and then we have our punctuation and stuff like that, I guess is the right way to call it. So this kind of defines scope and such. And then we've kind of got our other expressions like print, and we're going to take our stuff and we're going to do like, why does it look ugly? We're going to do like, hello, and then we're going to go back and we're going to close this off. Right, so here's our source code. Here's our shitty example, right? And then we feed this to the compiler, and the compiler is going to look at this kind of point by point and, you know, translate that into, you know, machine code, which is like our ones and zeros, and then our computer is happy with this, right? So this is the happy path, right? Now, what you need to think about is when the compiler gets to a point where you've declared a custom type. So the compiler has this notion of types, which as we saw with that green int there. So you've got like your integers, your floats, and all those things. You can also declare like a composite type, I guess is a decent way to call it, as determined by something like a struct, or a class, or a namespace, or something like that. So we're going to have our struct, and then we're going to call this like item, like how we had it. Right. Now, we gave this a kind. We gave this a kind. And we also gave it, like, sharpness. We gave it unbreaking. We gave it prot, etc. So these are our enchantment levels. And these kinds of things are going to change a lot during runtime. So the memory layout of this item is going to be the kind, and then the 3 enchantments kind of laid out byte by byte. Right. And that's kind of the usefulness of having everything in a structure. It's a structure of these more primitive types, as they're called. Right. Now, when the compiler sees this, it treats this as kind of... It's going to merge it all together in such a way where when you have an integer, right? So when you have, like, type int I equals 5, right? An integer, for our intents and purposes, we'll call this 4 bytes. So it literally maps out, like, 4 bytes, and that's how it stores your integer in your RAM, right? It literally flips, like, 32 transistors in your RAM and, like, sorts it out like that. But this is a compositive type, so this is going to be a 32 bits, and then we defined these as 8 and 8 and 8. And barring, what do you call it, when the compiler, like, tries to optimize the ordering or whatever, I'm blanking on what that's called off the top of my head. So we have 32 plus 8 is 40, 48, 56. So this is going to be like 56 bytes laid out in a row, and that's all at the end when the compiler is done is basically what it cares about. And each of these have an identifier that point into how far in this thing we are. So this is 1, 2, 3, 4, 5, 6, 7, 8. So we have 1 byte of kind of redundancy here, so forget about this. But each of these has an identifier that kind of tells the compiler, okay, the offset from the beginning of our item is where each of these are going to be. So at offset 32... well, at offset 0 is going to be our kind, right? And that's going to take up 32 bytes of information. Did I count 1, 2, 3, 4, 5, 6? Okay, no, I'm just stupid. We're going to take that. Then at 32 bytes, or at 32 bits after that, so 4 bytes after that, we're going to, this is our kind. We're going to have our enchantment 1, which is our sharp. And then at enchantment 2, we're going to have our unbreaking. And then at enchantment 3, we're going to have our prop, right? And that's the entire notion of what the compiler knows, and it's basically all that's given to us as the programmer as well once the program is compiled. Like, there's no way in normal C++ to ask, hey, you know, how many members are there? Even as a simple example, like this information is all that the program gets at runtime normally. So let's say for whatever reason, right, for a reason we just proved is very useful, we want to get the number of members. And in our example here, we kind of had it in such a way that they were sectioned off. So our enchantments here are kind of different from our item kind. So let's say, for example, we just wanted to get how many enchantments there were per item. There's no way to do that. So that's when this notion of reflection comes in. You kind of imagine what that means. Reflection is when the compiler looks in on itself and says, what information can we store about the type that we're currently compiling? So when you use the double caret operator, or the cat ears as they call it, on this E, it's easier to see here. So we're getting item enchantments. So this thing is kind of its own term. And then you're getting these cat ears operator, and that returns a meta object. And the meta object represents this structure at like a meta level. Like if you think about like a meta joke in like a movie or something, it means it's self-referential. Like it's looking in on itself. It's reflecting in on itself, right? So the meta object contains something such as a list of all of the meta objects that represent each of these. It's kind of like a tree. So you have this meta object that represents this item, which is a list of all the meta objects that represent its members. And, you know, for example, if we get the size of that list, now we have the number of of members there are in the structure. So that's, I mean, that's literally what we do in the enums thing up here. We get the enumerators of any enumeration. So this is an enumeration. We get its enumerators, which are all of these guys. We get a list of them, and we return its size. And that's how you get the number of enumerators for any given enum, not necessarily just items. Like, this is statically done because I know I only want to do this for enchantment info. And the way that I have this set up is specific to the way that I want to handle enchantments, right? But in theory, you can just make this a generic with a template, and like I did with the enums, and you can pass any enum into this up here. So we had get number of enumerators for the entity kind. What if I want to do this for the item kind? So keep in mind, let me kind of undo here. If I run main here and then run main, so it's more obvious. Oh my gosh. You kind of see up here, we have this entity kind, this player kind, this zombie kind. That comes directly from up here. So if I go down here and I change this to item kind, and then I run the compilation command again. Oh, I didn't save. Whoopsies. And I run it. Look at how easy that was to get the enumeration names as well. This is really useful for debug UI and stuff like that, I can tell you right now. In my current game, which I can't pull up right now just due to the way that I have my computer set up at the moment, you know, I have to do the separate list. You know, what is standard string item kind names item none kind sword kind bow kind, etc., right, and so on and so forth. You can imagine how big of a pain in the ass this is to maintain, right? And that was my point kind of earlier on. But yeah, where was I with that? So this is super powerful, as you just saw. I mean, what I was able to do there with that code is basically say, okay, I want to print a list at compile time, get all the enchantments at compile time, and then at runtime for each enchantment, print its current value. So like what we could do, right, is we can do test item dot enchantments dot sharpness equals like 18 now, and then we could get all item enchantments test item again, and just to prove that this is something that's happening at runtime, look at that. I guess I should have put a backslash n in there somewhere, but you can see it changes, right, as accordance to here. So at compile time, we get a list of all the enchantments, and then at runtime, we print their values. Look at how simple this is. I mean, what is this? Basic 2 lines of code? This, 3 lines of code. This line, the template for, and this. 3 lines of code. That is absurd. This syntax is absolutely disgustingly ugly. What are you? I don't like you. This should not look like this. This is unreadable. I hate the syntax. From a logic standpoint, this is great. I mean, this is slop. This is slop. But this is really cool. Yeah, I'm really, 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 really happy with how that turned out. No AI usage, just throwing that out there. You can do things. You don't need AI to do everything for you. What did that take? 2 hours to learn how to do this? If you can't spare 2 hours for something you love, what are you doing? What are you actually doing? That's really, really splendid. Okay, I think I'm going to go edit this down and make a video, because that went so much better than I thought it would. And I think that this will be really educational and make me look really good on job applications, because I will be attaching this video to every job application I send, because that's splendid. That's really, really splendid. Okay. Thank you for tuning in if you did. Appreciate having everyone. Sorry if I wasn't particularly chat involved. I just kind of wanted to write the code. I just wanted to put the code in the file. How do I end? I'll do it like how Moist Critical does it. Anyway, that's about it. See ya.